Hello, everyone. Welcome to the HoloWare Tech Podcast. I'm Mukund from HoloWare, and we are going to discuss display resolutions, examining how pixels and clarity combine to create the vivid images on our screens. Let's first start with the basics. What are pixels? Pixels are the fundamental building blocks of digital images. They are tiny dots that, when combined, form everything you see on a digital display. Each pixel can display a specific color, and when millions of these work together, they create the complex images we are used to seeing. Now, what exactly is resolution? It's the number of pixels a display has, typically expressed as width times height. For instance, a Full HD display has a resolution of 1920 by 1080. This means it has 1920 pixels across and 1080 pixels down the height, amounting to over 2 million pixels. The importance of resolution lies in its direct relationship with image clarity. Higher resolutions allow for more detailed, sharper images. Let's break down some common resolutions. HD or 720p. This has 1280 by 720 pixels, about 1 million in total. Full HD or 1080p. As mentioned earlier, this is 1920 by 1080 with over 2 million pixels. 4K or Ultra HD. This packs in 3840 by 2160 pixels. That's over 8 million pixels. 8K is the current pinnacle of consumer displays with 7680 by 4320 pixels, or about 33 million pixels. Each step up in resolution significantly increases the level of detail a display can show. However, it's worth noting that the human eye has limits on how much detail it can perceive, especially at a distance. This is why you'll often see higher pixel densities on smartphones as we hold them closer to our faces than we do TVs or computer monitors. You might wonder, if more pixels are better, why don't we just keep increasing resolution indefinitely? There are several factors to consider. Processing power. Higher resolutions require more powerful hardware, which can be costly and energy intensive. Content availability. There needs to be content created at higher resolutions to fully utilize the display capabilities. Diminishing returns. At a certain point, adding more pixels doesn't noticeably improve image quality to the human eye. Let's now touch on a few related concepts. Pixel density. This is the number of pixels per inch of a display, also known as PPI. Higher pixel densities generally result in sharper images. Aspect ratio. This is the proportion of a display's width to its height. Common ratios include 16 by 9 for most TVs and monitors and 21 by 9 for ultra wide displays. Refresh rate. While not directly related to resolution, this affects how smooth motion appears on the display. Higher refresh rates, measured in hertz, can make everything feel more responsive. As we look to the future, display technology continues to evolve. We are seeing advancements in micro LED and OLED technologies which promise even better color reproduction and contrast ratios. There is also growing interest in variable refresh rate displays, which can adapt to the content being shown for a smoother viewing experience. The future of displays lies not just in higher resolutions, but in smarter, more efficient screens that provide an optimal viewing experience while conserving energy. To wrap things up, understanding display resolutions and clarity is crucial in today's world. Whether you're choosing a new smartphone, setting up a home theater, or designing a user interface, knowing the basics of pixels and resolution can help you make informed decisions. Remember, the next time you're marveling at the crisp text on your phone or the stunning details in a 4K movie, you're witnessing millions of pixels working in harmony to create that experience. Thanks for tuning into the Holloware Tech Podcast. This is Mukund, and until next time, keep exploring the exciting world of technology. Thank you.